Hello there. So we'll be demonstrating the lab 2, which is essentially the socket tutorial on DETR lab. I've already created a DETR experiment, and what exactly we are doing is creating a network topology like this. This is the same basic.ns file which was provided in the first tutorial. So we have connected 5 nodes in this topology, and for socket we'll be working on node B and node D. We can use any of the nodes, but just for this demo sake I have used node B and node 2. Alright, so in the tutorial, as we see, most of the interprocess communication follow the client server model, and in this demo we'll be like creating a socket and communicating between server and client. The program is written in C, and it uses a couple of header files which we should have for it to work correctly, which are basically net inet in that in.h. These definitions are needed for creation of socket. So first I'll go through the regular code, uh, which uses TCP/IP underlying, and then I'll explain my enhancement to the code, and I'll also explain how we use UDP instead of TCP/IP in the code. So as you can see, this is the server code, and it's pretty basic. I mean, there is not much to explain other than the fact what you do is essentially have a structure which act as a data structure providing the server address and the client address. So you create a socket using this command. This specifically says this socket is using the TCP/IP protocol, and you get a file handle in the socket FD. And as we go along, we use this file handle to communicate with this socket. So we create the socket, and then we initialize the server data structure, and it's pretty much basic. What we get from the user is the port number for the server code, and we put in these data member values. Uh, and then what we do is basically bind this socket with this particular port address, and we listen to the connections on this socket. On the client, as soon as basically from the client side, if there's a communication, we accept that connection. So we accept requests from the client side using this command, and then what we do is essentially read from that connection, and once we are done, we write to that connection and we terminate both the sockets. On the client side, it's pretty much similar, other than the fact after doing the housekeeping, we also need the address of the server to which the client wants to communicate to. So we also need that as well, apart from the port address. So we create a data structure, server address, and we assign the correct data members. We assign that port number which we get. Then we call the connect function. If we are able to connect, it does not display any error. Otherwise, you get a prompt where you need to essentially enter characters what you will be sending to the server. Once that is done, you write using this buffer to the server. If the write is successful, it goes ahead. Otherwise, you get an error message. The server also responds, as you saw here. The server is responding saying I got your message. So the client reads from that particular port number. Once it reads it, prints it, closes, and just exits out. So both the process end uh, at the end of this program. So I'll be demonstrating it. Like I said, I'll be using Node B and Node D of the Dieter lab, which for the experiment which I have created. I've already logged in these two terminal shells, and the files, the code files are already present in my folder. So I'll just cd to that folder, compile it, and then run the program. So as you can see, after compiling on both the shells, uh, for the server side, as I run using server and the port number. On the client side, I specify the executable name and the name of the server. And this is the Dieter qualified name and the exact same port address. So as per the program, you see a prompt. The server side is essentially uh, is blocked. So this particular call is blocking. As soon as you get something here, the code will proceed. So I'll just specify my name here. You see from the server you got a message, I got your message, which is printed on the standard out. On the server side, you receive the message from the client, which says here's the message, Sparsh. So that's the basic code which uses TCP/IP to communicate. So this is the socket tutorial, the without enhancement one, the bare minimum, so to speak. We'll proceed to the UDP section. So the previous code was using TCP/IP protocol to communicate, but we can also use a UDP protocol to communicate between the server and the client process. And here are the two code files. So it says server underscore UDP and client underscore UDP. There's not much change from the server side code which we saw previously versus this particular file. The changes are specifically, as I mentioned, you need to mention sock underscore stream for TCP/IP. Sorry, TCP protocol, but for UDP you need to mention sock underscore dgram. Also, what happens on the server side, if you see here, you do not basically listen to connection in the UDP. You just bind it and use these two commands called receive from and send to. So receive from and send to. So unlike the TCP protocol where uh, you explicitly accept connections and on the client side you connect to the server, you don't do that here. UDP is a unreliable protocol, unlike TCP where it is guaranteed to receive back at the server and the client when there's a communication happening. But in UDP there are chances of packets being dropped. Other than that, it's pretty much similar. You use receive from and send to commands. You specify the socket ID, the file, the handle which you retrieved, and the buffer, what you want to send. This is essentially a character buffer, and you specify the client address. Yeah. So this particular section, if you think about it, will be same for both server and client. The server UDP and the client UDP. It's exactly the same. So, same as before, we'll be using the same nodes, and I will compile the programs. So like before, it's same thing, compile it and run. I've given a different port address because often this port gets blocked up by this process, and unless you swap out the experiment, this does not go free. So I've used different ports. That's about it. That's the only difference on the execution side. But it's the same prompt which you receive, and then you type in the characters which you want to send, and you receive the message. Same on the server side. So yeah, that was for the UDP. Now I'll be talking about the enhancement made to the code, which is using underlying TCP protocol itself, but the enhancement what is made is essentially to do with the process. So what exactly happens after doing the housekeeping and listening to the connection? uh, what we do is create a while loop in the server code, and in this while loop we have a new socket identifier which accepts connections, and if it finds a connection is there and it can accept it, it forks a new process. In this new particular process, what we do is call this do stuff function with the socket ID of the client, and here we print the message what we read after reading it from the buffer and send a confirmation to the client. Just to demonstrate this, what I have done is create a for loop, and in this for loop, one after one you get a prompt to specify the message which you want to send, and it gets sent to the server. But the advantage here is the process does not close off, and you keep on receiving messages to that particular port if there is anything there. So that's the whole enhancement side to the client server code using TCP. So just like before, we will be performing the experiment on node B and node D. Here you see on both these terminal I have logged to node B here and node D here, and I have changed my directory to the path where these particular code files are present. So I'll be compiling them. So I have compiled both the programs and running them on both these two shells as you see here. Now on the client side, as I type, so you see the server receives this message, a new process gets forked off, and the message is printed as per this do stuff code here. Sorry, here, and on the client side, you see because it's in a loop, I keep on typing the characters which I want to send, and I keep on receiving the message. You see for each of this line there's a new process and it prints on the standard output. So that's the enhancement made to the code, and this basically ensures there are no zombie process in the system, and essentially keeps everything tidy in the kernel. So that's it for the socket tutorial. Thanks. This is Sparsh Gupta.